For this lesson, we're going to look at collinear points, and we are going to do two examples. With the first question, it says that we need to show that these points, A, B, and C, so we are given 3 points, that they are collinear. So that needs to mean something to you. You need to know what collinear means. Points are collinear if they lie on the same line. So if we were to roughly plot, say I plot point A there, and point B goes there. I'm obviously not doing this very accurately. I'm just kind of plotting. If they lie on the same line, which they clearly do, then it means that they are collinear. So what do we know about straight lines? Well, what we need to know about straight line is that they share the same gradient. So the gradient between A and B will be the same as the gradient between B and C, and it will also be the same as the gradient between A and C. That's the thing about straight lines. The linear function has a constant gradient. So you can take any 2 points on a straight line and they will always give you the same gradient. I do apologize for that very messy sketch. Now, if they say show, it doesn't mean they want us to show like drawing a sketch like that. They want us to show that the gradients are the same. So if they want us to show that it is in fact collinear, we can go get the gradient between A and B. And so between A and B, and then we can go get the gradient. Let's get the gradient between A and C. And so in other words, we're getting that gradient of A and B and the gradient of A and C. And if they are the same, if those gradients are the same, it means that the points must be collinear, because it means that if the gradients are the same, then they must be on the same line. If we work it out and the gradients are not the same, it means they are not on the same line, and it means that they are not collinear. That can also happen. So in other words, we're going to use the gradient, the idea of calculating gradient. So you need to be so good at that. The gradient of A and B would be 5 minus 1. I'm subtracting my 2 y values and I'm starting with point B, and then I'm subtracting my 2 x values starting with B again. And that gives me 4 over 2, which is equal to 2. So I get that the gradient for AB is 2. Let's see what the gradient for AC is. The gradient for AC is equal to, I'm going to start with point C. All right, make sure that you agree with my substitution there. And that also gives me 2. So since these are the same, then it means that therefore A, B, and C are collinear, because that's what they wanted us to show, right? And since we showed that there's a constant gradient between those points, it means that they must be on the same line, so it means that they are collinear. Let's read. The following 3 points are collinear. So we don't have to show or prove that they are collinear. They are telling us they are collinear. So what does that mean? It means that they all are on the same straight line. With this one, I'll put in a proper straight line. So it means that A and B and C are all on the straight line because they tell us that they are collinear. It says that we have to find the value of y. Okay, so we've got some missing information there for coordinate C. So if A is there, B is there, and C is there, we've got some missing information for coordinate C. But since they tell us that the lines are collinear, we know that the gradient between these different points will all be the same. All right. Where's a good place to start? Well, we'll have to start by calculating the gradient between A and B, because there we've got all the information. We've got the whole coordinate of A and we've got the whole coordinate of B. I don't think it's a good idea to start with C, because then we won't be able to actually calculate the gradient. What I mean is, if you were to get the gradient between, say, B and C, you won't be able to actually get the gradient because there's a missing value over there. And we want to get what the gradient is equal to for this straight line. So that's why we start with the 2 points where we've got all the information. So I'm going to start with point A. 4, take away 2, that's my change in y's, and then my change in x. That gives me, am I right in saying that that's 2 over 2? Yes, so the gradient between A and B is equal to 1. They told us that they are collinear. So therefore, we know that the gradient between B and C will also be equal to 1 because they are collinear. They share the same gradient. So let's go calculate the gradient for BC. You could have also used A. I'm just choosing to use B. The change in y will be y. Take away 2 for coordinate B. There's my change in y's. And then -4, take away 0. And then we need to plug that in there. We have that gradient. We have that the gradient for BC is equal to 1. So we've got an equation that we're dealing with there. Y minus 2 over -4 minus 0, that would just be that. So let me just write this over there. So how are we going to solve this equation? Not just one way of looking at it. What I'm going to do is I'm going to multiply this side by -4. And the reason why I'm doing that is because then those two will cancel out. And as long as I do that on the other side as well. So if I multiply that side by -4. So then on the left-hand side, I get -4, and on the right-hand side, I am left with that. And then if I plus 2 on both sides, then it means my y will be equal to -2. So we just found, let me just put that there, coordinate C would be equal to -4 and -2. We used the idea of collinear points. They told us that the points are collinear. The knowledge that you need to have there, grade 10s, is you have to realize like, okay, so they all will have the same gradient between them if they are collinear.